Alright, how's it going everyone? Euler Gonzalez again, and today we're going to take a more hands-on approach on building and creating this reducers as a way to make sense, especially when you are building UI interface and how you can manage the state of your applications using Redux, this battle test state management application. And that's what we're gonna do. Let's going to jump straight forward to that, shall we? How are we able to test this? So yeah, there is a lot of things that we have talked about that. That to me is quite interesting. And here we are. Okay. Is this one? Really? Oh no, but this is our test for this immutability. Makes sense. Makes sense. Makes a lot of sense. Makes a lot of sense. And this is all about talking about reducers. Okay. Okay. Yep. Let's get into this. Let's get into this. So let me actually open is now the how to stay YAML file, React performance, driver row, no, createReducer, context, color swatch, out context, etiquette. What is this, bro? No. Comment.js, how to stake. React performance, no. We should close this because we're not gonna use this. We already end this. Yeah. We close that. Yeah, but pre-working directory here is this one. Okay. This is where we would like to go here. So instead of using it now, this thing we're gonna use is now is cursor. Right, so cursor. And here we want us to open is a new window, right? So this new window will open up is that's one of the things that I hate from this, the inability to open with SSH. Let me see, we got this, to get more. Accident, folders, no, okay. Anyway, let's go to open this thing here. This is not this, is in fact is the front-end master course, advanced Redux, and there we are. From the master super task, but now it's advanced Redux here. All right, let's get into this. Interesting. They gave me the ability to do this, that I can navigate through all of this. Okay. Okay, this is the Wordman. That's a way to see how you can improve the performance of the application, how to stake. The same for this. Okay. And now we are going to look is at this. No, it's not this one. Is the portfolio ticket client. Found pairs. accident counter, but this is, yeah, this is something that we want to do is, but with, this is the API design, like that, portfolio XGX, the tickets, source control. Where is it, man? There you go. All right. So here we are. This is what I want to share. And what now actually is sharing is this. No, this code in fact is cursor window here. No, cursor advanced Redux. There you got it. Advanced Redux. Okay, good. Here we are. Great. So that's what we're gonna do, is to now transform is what it is to transform the components, application and task. What is this? Create task, application, but no, this is all of these components. But what if we want to, for example, this is sleep, status, and context. Oh, I think this is on the accidental counter. Okay, is this one. So you got this library features here. So the whole point of this is to transform this actions and reducers by using is now createAction and createReducer. So let's get into this, shall we? So we can create our actions with a Redux toolkit by saying, hey, I want to create now these actions and then assign some names to that. This is when this thing started to make quite, let me actually zoom in here so you can see it here. This is when things with assignment and immutability, assignment immutability and value immutability comes here into place. If you're gonna use primitive, most of the time it is preferred to do this, right? Where you're going to indicate that, hey, this identifier that I'm going to put here as the increment, but in this case, I'm going to now create the actions. First, I'm going to provide now is the type, okay? And as you can see here is, you provide a type for this, or not only a type, but a prepare action that you want to do with that thing. But the type here is in a string, and you say, hey, you know what, this will be, is called increment, okay? And followed by this prepare actions. So this is the object that is going to create here, prepare these actions. Yeah, this prepare action here, a utility function to create an action creator for a given action string, which is an utility function, okay? That my question is that what is the thing that it accept this prepare action? It can be empty, a utility function. This action creator accept a single argument, which will be included in the action type object as field. But what is this argument that is gonna get? Okay, you receive one single argument, which is in this case the amount for our case, right? So this amount will be is a number, right? Remember that we are in TypeScript, so we are now in this two-level language. So you have now the JavaScript, which is in runtime. This is when values are generated. In TypeScript, which is the static. This is when types are generated. It's important to have this ability to think in the code when you do that. All right. And well, what we're gonna do is to actually is return something, because this is a utility function. Hey, let's go to return is the payload. I really love that it actually do this auto completion, or even here as well. It's a hey, it's payload, right? Payload. So the payload will be is whatever you pass in the amount, right? And not only that, look at how convenient is TypeScript, especially for providing us hint as we develop our applications. Okay, so one of the great thing of this is that despite the ability to, as a developer, from the developer's perspective, is that despite the ability to now run or catch error at build times, okay, it makes your code base more self-documented. One of so the value proposition of this for developer perspective, at least for my opinion, is that we can now have these nice little auto completion features that are very valuable, especially when you want to speed up the development process. So for that, by setting off TypeScript, by you defining as a TypeScript configuration object inside of your project, and especially if you're using now is React, you can do that for that. And the thing here is behind the scene, if you're using is now a fork of Visual Studio Code or Visual Studio Code, is using now this thing called the lang server. What it does is to check for errors in your file, TypeScript file, which is a great thing. And the other is that if you want to now run type or if you want to do a static analysis for all of your files, you can do it by run is the TypeScript compiler. This is something that we're gonna do, especially as you develop that as we define is now a static analysis for as part of the UI, the enterprise UI development. So right now, it's important to understand that this is one of the features and the advantage of using TypeScript. There also is a convenience. Yeah, there's also a convenient book, right? Let me see if I can show you this. Yeah, this is a convenient book here by Axel Rossmeyer. Shout out to him. So you have now TypeScript as well as JavaScript. All right, dive deep in theories in JavaScript as a way to look at what are the particular patterns in understanding the again, how you can work with types, values, and variables, and then working with data. One of the problems that occur when share immutable state and how to avoid that, which is something that as we look at some of the functional programming, so avoid sharing by copying data, again, this is one of the techniques that we are going to compile here, right? Again, avoiding mutations by updating non-destructive like that. So instead of doing that, you're just only going to copy that, preventing mutation by making data immutable. As you can see here, libraries for avoiding shared mutable state, immutable, and immer, but this is now looking at this advanced topic, especially when working with data. Object-oriented properties attributes, right? And OOP techniques, right? So for example, like instantiating a class or copying instance of class, immutable wrapper for collections, regular regular expressions, miscellaneous topic, meta programming with proxies. This is all of these kind of things that are relevant, especially more like the TypeScript here, that are relevant as you build your intuition and you develop now these kind of applications, as well as a body of knowledge and articulation or discussion when you need to actually dive deep into this topic as a way to make sense. How do we get here? So that's right. Back here to the code, back to the code, where the F is the code. Yeah, back to the code here, which is this. Is not this one. To this. Okay, so this is what we create here. We create our first actions, right? And then we can assign this to the an identifiable in here. So here we're telling JavaScript is like, hey, please reserve spacing memory for this identifiable called increment, whose values to whatever you're gonna put inside of this, it's gonna call this drawer, is a function, right? So if someone wants to try to change the content inside of that by reassigning that, please avoid that. Okay, please throw an error. Hey, and that's what will happen here. So okay, we can also create is another action. So we got increment and decrement, which contains the payload number. We create another action. We create action here that will be is now the decrement. Okay, and here it have this particularly prepare action, which is a utility function. Okay, this utility function that is going to take only one argument. In our case is the amount, it's number. Okay, remember that what we're doing is just migrating from simple Redux, okay, to now tools that provide RTKey to do that. So we have now the amount, right? And then we're going to return is now this action object with payload that'll be is the amount, right? And we're going to assign now this to a label called decrement. So JavaScript will create now, so now JavaScript will assign these variables with the label decrement, reserve spacing memory, whose value will be is a function, which is an object behind the scene, and a special type of objects that is callable. And for the another actions, we say, hey, create action. Okay, in this case is reset, and because we're not going to pass anything, okay, for reset, what we can do here is to just return is 0, right? So we say, hey, now the payload here, because we're not gonna, even though that we're gonna receive something, we don't expect to receive something, we can say is just, hey, it's going to return is a payload of 0, right? Just like that. Just to make this a little bit more convenient to work and less repetitive, we can say something like this. Hey, please, I just want to return is this object. No? Can we? Can we not? This is interesting. Okay. And then assign this actions, okay, to the reset. Okay, so far so good. So what we can do here is now replace that actions here easily, okay, inside of our reducer. So we can say, hey, instead of calling that, you can say is if the action type is decrement, okay, so in this case is the increment the type, right? It actually creating this object for us. Well, these actions increment payload. I think it is. This action increment, where you say, hey, this will be the increment dot a payload or amount. Yeah, exactly. It's like, interesting. We are not able to, because he's returning is that. Okay, similar to the decrement, we say, hey, decrement dot type, and similar to the reset, right? Say decrement, or in this case, reset dot type. Okay, so what he's doing is just creating what he's doing is just creating behind the scene is this create object actions. So far so good, right? There's no things wild that yeah, there is no wild things for that. What you can do is, for example, in the counter type or in the counter actions here, is to say, hey, instead of this, okay, instead of this, I want you to give me is this utility function called return type of the increment, and you can see it's gonna give you of the increment of the return type of the type of increment, and as you can see here, it say, hey, it can be one of this payload. That's great. That's awesome, right?
Return type, and if you look at the for free as well, but this is some decrement.
And as you can imagine here, you can say it's also something like this. It's like, hey, give me another. It can be the return type of this, or the type of decrement as well, or the return type of reset. Remember, we are now at the you can see it's actually doing that, you know, payload number, type increment number. So one of the great things of this is that we are now using a TypeScript as a way to also create those type for us. In this case, the actions for us. That's quite interesting.
I'm just here to get the same, like, only passing the arguments that work, so on and so forth. This is the same type that we had before. Payload undefined, number for the other two, boom, done. All convenient, no guessing, no manually having to try to figure it out yourself. Based on the code that you defined, you have declaratively also set up all the types, right? And, you know, I will make this point once again because Phil brought it up, like, you get fun, at least autocomplete and helpful hover hints in VS Code if you're in JavaScript. So, like, so at this point, like, just try it out, explore a little bit. Like, I did increment, if you want to try out decrement and reset, give it a shot, and we'll take a look.
This might be obvious, but this is basically replacing line 26 or 27, right?
Yep.
21.
So yeah, so now it's time to actually look at the how we can now create our reducer. So we to replace that, right? This is when things started to get interesting. So you can say, hey, const, we can say createReducer, which is now a function that is going to take the initial state here, all right, the state here, that is counter state, all right, yeah, the state where in this case you need to pass is that as an state, as an initial state, which is the count object. Okay, it receives now the initial state followed by a builder, this particularly called thing a builder notation in Redux. Okay, the createReducer, which is the builder notation here, that is doing a couple things here behind the scenes. It's doing a couple things behind the scenes, like so. So okay, the builder callback notation, okay, that allows us to add a case, add a matcher, and add a default case. Okay.
That's replacing 27.
Yeah, like this group is replacing this group down here, right? And with full, yeah, we have type safety. We used the createAction thing earlier, but like we get full support for everything. And again, when we start working on some larger things, like the other kind of piece that we can use is add default case and add if you want to on increment, right? I know what the action that comes out of this action creator is, like the same way we wrote that return value.
So the whole point of this is to, well, take a look at how we can create our reducer. So since this is now, let me see, this actually tell me exactly, this is now the builder callback, which is this utility function that allows to define is several things here with this reducer callback here, which is not only allowed to define is match add a case similar for reducer or a match that is useful. Let me see if I actually write that here. Tips. Exactly. Use createReducer for better TypeScript support. Add default only if you need to handle such cases. And add matcher is great for Thunks and async thunk. Question is that, what is a thunk? Here we go. You know, what is a thunk? That's a very interesting, valid question. That first, let me actually write how to write this builder, which receives now this builder. Say this is a utility function that is made of this action or the payload, all right, for mapping from actions type to case reducer. So this builder notation here is mapping its actions with reducer case. So here's when we started to create our cases. One of the great things is that it provides you now this auto completion feature. So add case, in this add case it say, hey, this is now the action creator. So add a case reducer to handle a single exactly type. So it can be either a type of that particular type or this type action creator, which is in our case is this assignment that we did. For example, the increment, right? And as a second argument, now the reducer. which add a case reducer to handle a single exact action type. So this is when we're going to handle this in this reducer, right? Add a case reducer to handle a single exact action type. Let me see if I can read that, which is the add case action creator, right? And the reducer, which is a case reducer. What is a case reducer? It's a good question. Yeah, what is a case reducer? Case reducer. If you take a look at, say, case reducer. Case reducer from that. Case reducer. You have this case reducer. Case reducer. If you take a look at the case reducer, it says that this is now, we're doing this as a way to now understand where the things are coming from. Explore declarative type, which is this. In fact, this case reducer means that this is now a genetic is generate is types for that. In this case, is it is made of a S, which can be anything, and another type that must extend from the action. Okay, and the signature is now this, which is an action that must return is this state or this S type, right? It can be void or it can return as a new draft here. This is when they say a case reducer is a reducer function for a specific action type. Case reducer can be composed to full reducer with using createReducer. Who made this? Can I see blame this? Get blame here? No. It lands. All right. Open Git license. Yeah, but for the workspace or for the user, inline in blame. That's right. Git go lens status like that. But the question is that why can't I see this? For this I can see who made this. Well, uncommitted. Okay. But as you can see, I can see the this. But here for the types, interesting. On types, I can see that. At least not for the definitions. But they're using is now Immer. This immutable data structure. This mechanisms to know when a needed mutation or when a needed change to a value occur. So we now have the ability to keep track of when those update mutations change. But in any case, I don't want to go dive deep too much in this. But as you can see, we are now able to return is now this, right? We're able to return is this is pretty much like a similar reducer function that is take a state and an action to generate a new bit of a state. It can be nothing, okay, which is now you are delegating is that to Immer, which is what is using behind the scenes. This does not actually cause the stored state to be mutated directly. Instead, thanks to Immer, the mutations are translated to copy operation that result in a new state. Which now this Immer and immutability GS are just mechanisms in which you can now control when a state change, when a value in a object property chains. So you can have now this deterministic behavior of what change happens to you. And the way, for example, now immutability JS works, which is from the Thunks of React, is, well, here we're going to, instead of actually creating a new copy and anytime churn the CPU and memory to do that, right? We're just going to create a new object with the new information and internally point it back to whatever it is, and internally point it to whatever it was, and internally point it to whatever it, and internally, and internally have a pointer to previous one, to the previous objects. Okay, that's what it's doing. So you can think of this pretty much like Git, right? Where this only store is the current diff, all right? It only store a diff and compare with what was before. That's exactly what is doing this immutable JS behind the scenes, according to Kyle Simpson. So now you're starting to understand what all of this is doing behind the scenes. All right, good. So it means that after all, this is the Reducer. Holy hell. And what you have now, things like writable draft kind of thing, because now what happened is that Imer, the way how this process this immutable data structure is to say, hey, give me now the new state, the current state. I'm going to create now a draft where here is going to manage all of these mutations. And once that is done, then I'm going to create this new object with this new information. And it's using behind the scenes is proxy as a way to detect when an object value change. That's interesting, bro. Okay. So you have now this, right? State and actions. So yeah, this is now the state and this is now our action. Okay. And here we can do a couple of things. We can or not returning anything. And what it's doing is using Imer behind the scenes by saying is, hey, state.count. All right, what the French stuff is this? 0, and it's going to inherit that, so you don't have to explicitly have to tell what is the type of this count. All right, and then you say, well, whatever I am getting from the payload, it'll be right. So because we want is to assign is whatever the previous state has, we do this. So hey, let's go to assign whatever the previous state has, increase that, okay, and then assign that to the newest value. So yeah, pretty much like that. Actually, it's not that wild to understand.
So at this point, like, just try out a bunch of things, like the ability to do
right?
this, like,
method of the builder is
I remember this one. And also, we know the payload is a number, so that'll work.
Okay.
Yeah, good call. I was mostly just
I
showing
couldn't
off.
tell if you were joking when you said you weren't going to write a bug.
And also, we know because it has.
Dude,
Yeah.
why do you have action after state in the argument there?
and then return that. So
Yep, all that's repair for me. And also, we know the payload is a number.
And you would export line 20, right?
Yeah, just export that. And that's a regular reducer. Pop it into your existing Redux infrastructure.
So this is quite interesting. This is a regular reducer. Because exactly, this is a regular reducer. pop it into your pop it into your existing Redux app. All right. But the convenient thing is that it's not going to provide you TypeScript support and immutability of that data using behind the scenes.
Pop it and use Reducer. Right? Like, go for it.
All right.
Sure, there's a reason. Really speak.
So as a way to also add all of these and other cases, here we say, hey, this nice little utility function that allows to add cases in a TypeScript friendly manner and to prevent some errors when we are now defining the reducer to which action you need to follow. All right, where the first argument is now the type action, something that we already defined, that which is decrement in this case, followed by the normal function reducer, which takes this the state and an action. Okay, you can also destructure is the action here for that, right, by saying is this payload, right? You can say, hey, this argument that I'm receiving, give me only the payload for that. Okay, and then I can do now is this. It's like, hey, state dot count. Let me actually do this in this case, so we can now actually do this. So we can destructure is the count from that object, which means we are going to work with the count directly. And then I want is to decrement that whatever you have in the payload, right? Pretty straightforward. This one, yeah, it's a expected an assignment or function call instead of a saw expression. Assign an assignment or function call. Of course, especially an assignment or a function call. The function call, yeah. yeah. It's like this. Action and a state, okay. Then you say state.count and the action.payload. That's right, but for some reason it's now complaining quite a little bit. It's a now expected an assignment or function call instead of a saw expression. An assignment or a function call. An assignment or a function call. You mean this, like that? Okay. Oh, because it's now run. Okay, because this is a utility function. It's running. And, oh, it's it's telling you. It's being explicitly. Only you have to is read what the hint is given to you, do a little bit of code introspections, where a lot of the time this is the right fastest way to find your way in. Oh my God, it's telling you here is that, hey, I'm expecting an assignment or a function call instead of a saw expression. Because what it's doing is now calling these functions and generating is this reducer behind the scenes. Okay, so builder, it's a add case here where you say reset, pretty much the same stuff, but in this case we want it to only work with this state, which can be count. Okay, we don't need the action, and we say, because we want is to now modify is the state of these applications. So we say, all right, please do that for us.
Speaking, there are actions that you ignore all the time, right? And
one of the things here that it mentioned is that, hey, this reducer stuff here is at default and at a matcher here. This reducer stuff here is something that, this actually generating is a normal reducer, and he's talking about the at default, right? So at default is only used when you need to, and the at matcher is for Thunks.
That is a feature that I greatly admire in Redux. So I don't personally value this one. Add matcher is very good for like Thunks and asynchronous things, where it's like if you had like toast notifications that came up and you want to respond to any time a network request has is rejected state, right? And you'd be like, oh, couldn't fetch this, or you needed to maybe do something, and update your state in some way around that, or maybe you had middleware. Right, I guess in the reducer, you're only caring about the actual updating of the state. Right, but you wanted to add a notification to your notifications array, something like that. You can catch anything that matches is rejected. There are use cases for that one, particularly in asynchronous situations. I wouldn't abuse it too much for known cases of I'm just going to match everything that kind of looks like this. Just
exactly. I wouldn't abuse. That's one of the reasons why. Okay, good. Especially when you have a tool like that in their use case, I wouldn't abuse of outside of the use case. It is your job. It's up to you. You're free to go into your own adventures, which is great. Yeah.
Either, how do I put this nicely? Rethink what you're doing. Right, write some better actions or something along those lines. Occasionally.
So add matcher. Let's go to take a look at this. Add matcher in Redux. Okay. Jump here. Yep. Matching utilities. Okay. So Redux Toolkit explores several type-safe actions. Utilities that can leverage when checking for a specific kind of action. They are primarily useful for these are primarily useful for the builder.add_matcher case in create slides and createReducer, as well as when writing custom middleware. Here we are. Okay, when you're writing custom middlewares in Redux, or when you want to use this matcher. General purpose is all off, is any off. Return true when all conditions are met. Return true when at least one of the conditions are met. Okay, create async thunk, specify specific matchers. All these matchers can either be called with one or more thunks. What in the French toast is thunk as an argument, in which case they will return a matcher function for that condition and thunk or with one actions, in which case they will be matched for any thunk action with say condition. Async thunk action is pending, is fulfilled, is rejected, is rejected with value. But the French does this is like is async thunk action. It's a high order function that returns a type guard function, okay, that may be used to check whether an action was created by createAsync thunk. Oh my god. createAsync is pending, is fulfill, is reject with a value using matchers to reduce code complexity, duplication, and boilerplate. Using matcher as a TypeScript type guard. Okay. Yeah, but there is some couple interest in here. This is the reducer. Okay, pretty much like when you do this with creating your reducer. You pass it decrement, you create your actions, manual increment async, okay, like that. Counter slice. Here you're passing is that. Then you're going to update that. As you can see behind the scenes, you are doing an immutable like syntax because behind the scene is using Imer for that. So instead of you having to generate a new state or create that new state, is actually Imer that is creating is this immutable data. Is this a data that has, is this data, is this data that need to be mutated? Is this data, okay, is an object, okay, this immutable data, which is an object that represents it's an object that represents a layer of control that prevent unexpected mutation. Okay, it's a layer of control that prevent from unexpected mutations by exposing an API. So consumer can have access to previous version of the data if they need to. Interesting this. So, okay, this is one of the concepts of this immutability data. All right. When we're talking about immutability data in the context of software, it means that is an object that is an object representing a control layer that exposes an API to prevent unexpected mutations. So consumers can see previous states of this data. Holy F. Think of this as the Git diff, right? When you store the diff, when each time you store is a diff based on, you store is a diff from the previous one. So we can think of this that is behind the scene is using some sort of a linked list, okay, as a way to now and to record this capability of have access to the previous states. Holy moly, bro. That's French does well. Okay. And then you got the extra reducer, the builder at a matcher and else's. My question is that what in the F is a thunk, bro? You know, is createAsync thunk? Exactly. createAsync thunk will generate 3 Redux actions. Okay. Creators using createAction, pending, fulfill, and rejected. Okay, it again is it's generating all of these ceremonies for you. All right. Serialized error. Each lifecycle creator will be attached to the return thunk action creator so that your reducer logic can reference the action types and respond to the action when dispatched. So the reducer logic can reference the action types and respond to the action when they dispatch. Okay, so you are linking that based on this reducer logic. Serialized errors, pending actions, thunk, fulfill actions, rejected actions, rejected with value actions. What? This is all what is generating? The action creator will have this signature. Oh shit. Pending action, thunk argument. Fulfill action with the type and the payload, promise result, and the metadata and request ID and argument thunk arg. Reject action, okay, serialized error or nothing, and then you need to define it rejected with value action, and then you need to define is the pending state. The pending, which is now a thunk argument, which is a function that take an ID and an argument to generate is a pending action of that thunk argument. Fulfill, that is generate is this new state, okay, or the new type, all right, where this will be is a fulfill action, and this fulfill action is now an object with this, okay, with the thunk and the promise result, similar to the rejected, and this. What in the F is this thing called thunk arg, bro? You know, what is this thing called thunk arg, bro? Question, are we going to see that? I assume that. Okay, oh my god. Okay, handling thunk results, holy F. Handling thunk errors, but what is, say, thunk, bro? Thunks, handling thunks result. Oh my god. Jesus. Okay, let me take a look now at frontend master here. They changed that. CrowdStrike. Anyway. Charlie Gerard. In socket. Machine learning in JavaScript with TensorFlow. Socket. Thunk. I think Cal Simpson is going to tell me more about that. Async thunk with React Toolkit. No, it's like, what in the F is a thunk, bro? Exactly. Is this? No F, bro. Yeah, what is a thunk, bro? Observable CPS. The generators. Wow, this was, I think this was something all while ago. Yeah, what in the F is this? Rethinking asynchronous JavaScript. Damn, that's like very good. Okay. Redux Thunk solution. Okay, Thunk. But I think this is something quite old, by the way. Exactly. With Redux and MobX. Oh shit. Okay. Okay.
One thing that we haven't talked about in this entire time is what do we do about asynchronous code? Right? We have just been storing stuff in an array, and it's been blissfully easy because we haven't had to talk to a server or a database or anything along those lines, or local storage or anything asynchronous. And what?
All right, let's talk about a pattern on top of callbacks. This has actually been around for a really, really long time. It way predates JavaScript.
What the fuck? The way predates JavaScript. The hell is this, man? Thunk. Why in the French toast called thunk, bro? Okay, please.
This terminology didn't even really exist in JavaScript until people started trying to adapt this notion in JavaScript, and the word is thunk. I have no idea where they came up with this word. I don't know what they were smoking. I wish I had some of it.
Ming is like, what the French toast is this, man? What they was smoking, man? Come on, man. What you were smoking with thunk? Oh shit. Let me see if actually thunks appears in MDN docs, right? What is a sum MDN docs? Jesus, it's like what the French does this one? Thunks middleware for Redux. Redux Thunk. Oh, here we are. Okay, because remember that after all, Redux allows us to conveniently now add different. The more input a particular state needs to react, the more it makes sense to have now a function that gives us a deterministic behavior to update the state, right? So if we want to add now more functionality, we want to add now more inputs that this state needs to react, that makes a lot of sense to create middlewares for that, which is a piece of software that now is going to run it is a series, is a collection of functions that is going to be run one after the another, right? And they sit between your state updating, and they sit between your and they sit between your state updating that. Jesus, French those guys, man. Thunk middleware Redux. Okay, Thunks. Okay, is allowed for writing functions with logic inside that can interact with Redux store, dispatch, and get state. But this, if you're using our official Redux toolkit package as recommended, there is nothing to install. Rkey configure store actually API already add the Thunk middleware to that. Manual setup, injecting a custom arguments for that. Why do we need this? With a plain basic Redux store, you can only do simple synchronous updates. So the more inputs that an state needs to react, the more it makes to have this particular function, this maintainable way to update the state. But this is for synchronous operations. So for example, like user events. So any synchronous operations, we have that. But what happened when, especially when we're building web applications, async things will happen. Of course, we need to fetch data from the server, or we need to talk to a browser API and wait for that to respond, or any user input as well. So for all of this input and output that we need to wait for it, all right, middlewares extend the store abilities and lets you write async logic that interact with the store. Thunks are recommended middleware for basic Redux side effect logics, including complex synchronous logic that need to access the store, and simple async logic with AJAX requests. Writing logic with Thunks. Stack Overflow dispatch Redux actions with with a timeout. Stack Overflow. Why do we need a middleware for async flow in Redux? Oh, for handling that, Amabrof give reason for using Thunk and async middlewares, and some useful pattern for using Thunks. What the heck is a Thunk? That's where I am. Thunks in Redux, the basics. Okay, what the heck is a thunk? The sound you what's a thunk? The sound your head makes when you first hear about Redux thunk. Okay, sorry, that was awful. But seriously, who the fuck are you? Dave City. Yeah. A video editor called Recap. Okay, interesting. Noise. All right. Okay, that's interesting. And link from JavaScript dev. Mm-hmm. 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 And it's interesting because it's using the mutation observer here. Interesting Redux. But I think this is a video. And this is a svelte. Damn, son. Remove the first node from the list. Interesting.
Helped me redesign the Recut landing page recently, and he did such an amazing job. I ran across his work on Twitter, and I'd been thinking about redesigning the site for a little while. But I'm a developer, and I designed it myself, but I could never really get it to look like I wanted it to. There's always something missing. So when I saw Krish's work, I was super impressed. It looked like he got all the little details right and everything, the kind of stuff that I couldn't really do myself. So I reached out to him, and he got back to me right away, and we just worked together pretty much constantly over the next couple weeks, constantly back and forth. I love that we worked on it collaboratively, and he did more than just the design too. He researched my customers, he figured out pain points, and helped write the copy and everything.
That's interesting. Visual Guide to GS reference. Okay. Yeah. Interesting. Very, very interesting. It's all both. Okay. Thunk is another word for a function, but it's not just an old function. It's a special and uncommon name for a function that returns by another, like this. You already know this pattern. It's like, hey, this function is returning as another new function. Okay. So what you're doing is just creating a closure here, which means that this thunk, this function that is returning that is a closure, which means is that it stores the information this function store the information. This function can have access and store the variables outside of the scope and make it available inside of that scope. Okay. You just don't call it thunk. If you want to execute the do stuff now, you'll have to call it like wrapper and then calling it twice, basically. So, okay, you're calling again. If you're familiar with Redux, you'll know that it got few main concepts. They are actions creator, reducers, and middlewares. So far we are quite. Actions are boring. A very small library indeed. But this is talking about is that. Okay, that's quite interesting here about this. Okay, Thunks.
It's a weird word. I don't even know what its origin is, but I can describe to you what a thunk is, and it's actually kind of deceptively simple. What a
thunk. I don't know what this smoking is for real. It's like thunk. Is that? Oh my god, who made this? It's a computer. Oh shit. Here we go. A thunk is a subroutine or a function used to inject a calculation into another subroutine. In early years of compilers, research saw broad experimentation with different evaluation strategies. Okay. A key question was how to compile a subroutine, call it, if the argument can be arbitrary mathematical expression rather than constant. One approach known as the call by value calculates all the arguments before the call and then pass the resulting value to the subroutine. In the rival call by name approach, the subroutine receives the unevaluated argument expression you must evaluate. A simple implementation of call by name. As an improvement, the compiler can generate a helpless subroutine called Thunks that calculates the value of the argument. Calculate the value of the argument. Okay. Jesus, I don't know what they're smoking, bro. This is a term that predate. Oh my god, this is a term that predates JavaScript.
What a thunk is.
Okay.
Callbacks. This has actually been around for a really, really long time. It way predates JavaScript. This terminology didn't even really exist in JavaScript until people started trying to adapt this notion in JavaScript, and the word is thunk. I have no idea where they came up with this word. I don't know what they were smoking.
I don't know idea why they came up.
I wish I had until people started trying to adapt.
I don't know why they come up with something like this.
This notion in JavaScript, and the word is thunk. I have no idea where they came up with this word.
Yeah, I don't have idea why they came up with this word.
I don't know what they were smoking. I wish I had some.
I don't know what they were smoking, so I wish I had some.
It's a weird word. I don't even know what its origin is. But I can describe to you what a thunk is. And it's actually kind of deceptively simple what a thunk is. From a synchronous perspective, a thunk is a function that has everything already that it needs to do to give you some value back. You do not need to pass any arguments in. You simply call it, and it will give you a value back. Does that sound familiar?
Okay, this is a function.
You remember how we were talking about that before in a different workshop? So a thunk is just a function with some closured state keeping track of some value or values, and it gives you those things back whenever you call the function. Here's a synchronous thunk. I've got an add function which expects an x and a y, and I make a thunk that calls the add function, and it already has the 10 and the 15 in it. It's hard-coded in this case. So every time I call, like I do on line, so that's line 6 to call the add function, but every time I call line 9, if I call thunk over and over and over again, I'm going to get the same value out every single time. So now, here's the important part. Thunk itself, that value which is a function, it has become a container around that particular collection of state. And that is now a container that I can pass around anywhere in my program as a container wrapped around that state. And anytime I want to extract it, I simply have to call that function and I get the value out. I don't have to pass the value or the state itself. I pass the wrapper around that state all around my program.
Is this portability and predictability that this thing that you're passing here?
So it becomes like a token that represents this value, and it's easy to get it out. All I have to do is execute it to get the value.
Because like a token that represents this value.
You may not realize it yet, but that is the fundamental conceptual underpinning for what a promise is. A wrapper around a value.
Yeah, a wrapper around the value. So you can have a token around this value, and then share that in any place where they need that.
Here, the wrapper is a function. In promises, it's a much more sophisticated thing. But it's actually quite powerful to think about when we extend thunks from the synchronous nature into an asynchronous nature. This is a synchronous thunk, and that's the most common definition for thunks you'll find is that it's a synchronous thunk. What is an asynchronous thunk? Well, there's no right or wrong definition here, but the most natural way that we could define an asynchronous thunk is that it is a function that doesn't need any arguments passed to it to do its job, except you need to pass it a callback so that you can get the value out. So that's what we're going to call an asynchronous thunk. So let's extend our synchronous thunk to an asynchronous thunk. I have an add async function. It fakes some asynchronicity with a set timeout. Takes the callback that you've passed in on line 1. On line 3, it calls it with the addition. So we make our thunk on line 7 with add async, and we hard code 10, 15 in CB. And on line 11, we have that value, that thunk value, that we can pass around our function. And every time we call thunk and pass in a callback, we know we're going to get our value out. But here's what's incredibly powerful about this pattern. From the outside world, we do not know, nor do we have to care, whether that value is available immediately or whether it's going to take a while to get us that value. What difference does it make to us? We have to care to get our value out. But here's what's incredibly powerful about this pattern. From the outside world, we do not know, nor do we have to care, whether that value is available immediately or whether it's going to take a while to get us that value. What difference does it make to us? We pass in a callback. We know you'll call the callback when you have a value ready for us. So the first time we call thunk and we pass in a callback, it might have to do some significant work to calculate the answer to our question. It might make some AJAX call and do some other kind of crazy calculations, and it might take a while. And then it may decide to memorize the answer to that question.
Exactly.
So that the next time you call it, it just gives you the value back right away. But from the outside world, does it matter to us whatsoever how that works?
No.
What's happening here is that by wrapping this function around the state and allowing it to be asynchronous in nature, we have essentially normalized time out of the equation. We have factored time out of the equation. We have
normalized time out, so we
produced a wrapper
care
around the value that has become time independent. It out of the equation. We have factored time out of the equation. We have produced a wrapper around the value that has become time independent. It doesn't matter if the value is there now or if it's going to come later, we still use it in exactly the same way. Hear this if you don't hear anything
but
else.
It's about things in this particular pattern is things to this observer pattern, to this callback here. When that value is done, it's going to perform that, it's going to execute that. However, we're passing these instructions here, or we are now holding is a reference of the value that when that happens, we're gonna get that. And we're gonna get that so we can use that independently in our applications. So by holding a reference of that state or that callback function, which is gonna run at any time is in the future, right? And when we want to use that wrapper, so we to pass now an state that we want to now returns some operation that will take some time, we're going to get that value when that is available. Make that value portable across our entire applications, and therefore don't need to worry. And therefore no need to worry about, and therefore we have now a reference of that data whenever we want to use it. But again, the idea here is that we are passing is now this async functions here, where we're passing here is now is a set of instructions that will run at some times in the future, okay? And then once those instructions has been completed, the value of this, okay, is something that we care, We already have a reference to that when that operation has been, when all of this set of instructions has been done, okay? And then we can have access to this. Okay, it's slowly to make sense.
That's what I've said today. Time is the most complex factor of state in your program. Managing time is the most complex state in your program. That's why this is huge. Complex factor.
Yeah, time is what is the most complex factor of state.
Of state in your program.
I don't know what. Definitely the software engineer. I don't know what they're smoking about, but I would like to some of it. I don't know what Pythagoras was thinking about, or what is smoking. Perhaps what kind of fungus family they were eating with wine in jest, but it's like holy French toast. It's like a gateway to reveal the nature of life.
Managing time is the most complex state in your program. That's why this is huge, to be able to come up with a very simple, there's no libraries involved. This is straight up code.
Exactly. There is no library involved. This is just straight browse. This is just a straight JavaScript core.
Or JavaScript, just a different way of looking at and using the mechanisms that have been available to us for all 20 years. We've taken this notion, this fundamentally difficult thing to reason about called time, and we've eliminated it as a confusing factor, as a complicating factor. I have this thunk. It represents a value. I pass it around. Whenever I want the value, I give it a callback, and I get the value out. And that's all I have to do. It represents a difficult thing to reason about called time, and we've eliminated it as a confusing factor, as a complicating factor. I have this thunk. It represents a value.
Exactly. I have this thunk that represents this value.
I pass it around whenever I want the value.
I'm passing around.
I give it a callback, and I get the value out.
I have this thunk that represents a value. I'm passing the values that it needs to in a callback. And I get the value out of that.
And that's all I have to do.
And I get and I pass you a callback.
I can tell from your faces that you're not realizing how groundbreaking that notion is. Okay? But that is one of the most important observations. I couldn't believe when I recognized what that meant. I could not believe how far I had gotten in JavaScript without that realization. It changed everything for me. And in fact, it's what helped me understand promises. I didn't fully understand the conceptual basis for promises until I understood what Thunks were doing. Because we'll find out that a promise is a time-independent wrapper around a value.
A promise is a time-independent wrapper around a value. Oh, shit. I don't know what kind of drug they're consuming, bro, but it's pretty fucked up, man. Oh shit! I don't know what they're smoking on, but yeah, it's like a value is, or a promise is a reference to a value that is time independent. So I don't care when that happened. I just only care that I'm gonna get that value.
Conceptual basis for promises until I understood what Thunks were doing. Because we'll find out that a promise is a time-independent wrapper around a value.
Promise is a time-independent wrapper of a value, bro. Promise is a time-independent value. Promise is a time-independent reference to a value or a wrapper around a value. Promise is a time independent wrapper around a value.
Just has a fancier API. So as I said earlier, I like to say that Thunks are promises without the fancy API. Okay? Now, there are some twists, there are some wrinkles that we can throw into the situation. If I wanted to make a thunk, give myself a generalized utility for making thunks, I can do all that old crappy array stuff and pushing the arguments on and calling a.
So what you're doing here is just to get all of these arguments and assigning into a variable, which is now function scope here, and then creating an array that is going to slide call, which means creating an array with all of the argument, which is a global, which is a function execution from all of this argument here, and you're gonna put all of this into an array of a collections of arguments here. And then once you store that, you say, hey, you know what, I'm going to create now this thong or this closure here. We're going to, when you call me the second time, I'm going to pass you now is this callback, where I'm going to push now all of, where in each one of, we're going to now, in this collection of arguments, the last element will have the callback, and then I'm going to now run interesting, and then I'm going to now call this function, alright, and apply and bind here. Call and applying is just a way of how you can call the callback, and I'm going to call this callback with all of these arguments here. So I'm going to call these functions with all of these arguments here.
Why? I could do it that way. And I could use it this way, as we see on line 7. So now I'm not manually making one, but I can make any thunk that I want by presetting.
But remember, after all this thunk, what it's doing is to hold you a value that is time independent.
The callback is the first argument, and anything else that I pass.
The callback is the first argument in this case. Make thunk here. Exactly. The call, because here what you're doing is just passing is a function here. Okay. And any of the argument that you
I could use it this way, as we see on line 7. So now I'm not manually making one, but I can make any thunk that I want by presetting. The callback is the first argument, and anything else that I pass, it's going to get passed along to it always. And that's how I could produce my thunk. So I could make myself a utility for making these, which would be not fundamentally terribly different from a promise constructor. Make thunk would be kind of like a promise constructor. It's a constructor for thunk.
It's a constructor for thunk. It's a constructor for this time independent value that we this time independent wrapper around the value. In this case, is just preparing everything needed to, this is the function that I'm gonna execute, followed by the arguments here, and I'm going to run that at any time when I now call them.
Yes.
Could you go through the, so when we talked about the problems of callbacks, this inversion of control, not too early, not too late, not too many times. In the problems of callbacks, this inversion of control, not too early, not too late, not too many times. In just expound a little bit on problems of callbacks. This inversion of control, not too early, not too late, not too many times. In just expound a little bit on that with how the promise thunk is.
We're actually not gonna have any solution to inversion of control with thunks.
Yeah. Okay.
Promises are gonna solve inversion of control. But we're not quite there.
Yeah. Okay. That makes me more.
Yeah, we haven't solved inversion of control. Solution to
just expound a little bit of callbacks. This inversion of control, not too early, not too late.
Not too early, not too late.
not too many times.
Inversion of control is not too really, not too late, not too many times. Very specific.
So when we talked about the problems of callbacks, this inversion of control, not too early, not too late, not too many times. And just expound a little bit on that with how the promised thunk is.
We're not gonna. We're actually not gonna have any solution to inversion of control with Thunks.
Yeah. Okay.
Promises are gonna solve inversion of control. But
Okay.
we're not quite there.
Yeah. Okay. That makes me more.
Yeah, we haven't solved inversion of control yet. We're laying the conceptual underpinning for promises, and that's why we're looking at that.
Yeah. I just wanted to, because that realization happened earlier when we were like, now getting at better understanding of what promises are.
Yep.
And just wasn't sure how much the fancy API is, solving our problems, or how much is it is the thunk.
But
So-
too early, not too late.
Yeah, got it. The Thunks really aren't addressing inversion of control. The nature of how promises are designed to solve that. So we'll get there. Okay.
Okay.
There's a question about going over slide 39 again. This is a synchronous thunk. As you can see, I have an add function that receives an X and a Y, and I make another function called thunk, which doesn't need any arguments at all. Thunk can simply be called because it is hard-coded to know to call the add function on line 6.
Exactly.
And it's hard-coded to know to pass in the values 10 and 15, also on line 6. So everywhere we do something like we do on line 9, we're going to get the exact same value out. That's a synchronous thunk. Slide 40, the asynchronous version. Exactly the same concept, except we need to pass in a callback.
We need to pass
to our
in a
thunk.
callback here. So what is the thing that we
So
want
line
to
11,
run?
I can't just call thunk and get the value as a return value. I have to call thunk and give it a callback, which will receive that value as I do on line 11. You're going to get a chance to practice with thunks, I promise. All right, so here's a rewriting of that silly running example calculating the meaning of life, but using thunks. Now you notice something slightly different from what I do before. On lines 1 and 2, I pre-create some thunks. I say that get10
Create some-
needs to,
exactly.
when it's invoked, call getData with the value 10. So line 1 has not actually made that AJAX request yet. That's important to understand. All we've done is create a wrapper that when called will do that AJAX request. Okay? So I preset up the get10 and the get30
I thought that
thunks.
when we call
And I can
them-
start using them. So on line 4, I use it, call get10, give it a callback. I know 1,000 milliseconds from now, num1 will have the value 10. Then I use the get30 thunk on line 6. Now you notice on line 9, I create another thunk.
Yeah,
Why couldn't I create that thunk?
We just create here. What we just create here now is thunks, all right, with the parameters, whatever get data it is, whatever get function it is, at the moment that we're passing to, followed by the arguments. Okay, so the first argument that we pass into this thunk is this, and then we just actually is wrapping
The one from line 9, why couldn't I pre-create that up on line 3? Because it's temporarily dependent upon the responses from the first 2 thunks. Does everybody see that? So that's why I had to defer the creation of that particular thunk. But on line 13, I can simply call getAnswer, which is my thunk, and I will retrieve that. Now getAnswer happens.
which is not my thunk. Make thunk get data, which now contains a reference to this. The meaning of life is now okay. So now you are actually is calling this thunk with the proper data that now has a reference, which is time independent of what went wrong or what happened next, and get access to this.
To be a container around that value, and I can pass getAnswer all over my program, and anybody that needs the meaning of life can simply call that, give it a callback, and get the answer back. Now there's something really important to note here, as I said, it's important to note that this particular expression of a thunk is what I guess I would call a lazy thunk, if I was really trying to come up with some terminology for it. It's a lazy thunk in that it doesn't do the work until you call it the first time. You could make an active thunk which did the work and just held on to its response. So it did the work right away and held on to the response. That is another way of doing a thunk. And I'm giving you a gigantic hint for your upcoming exercise.
Is it like deferring a promise or something?
It's a lot like a promise. That's why I'm saying these are the conceptual underpinnings. So our current expression of thunks is very lazy. It is possible to do thunks in a different way, which they are active. That means the first time they're called, the first time they're set up, they do the work, and they don't give you the answer until you pass in the callback. Exercise 2 calls for you to do the exact same thing as we did in exercise 1, except now we're going to use thunks. Okay? So if you open up the README in the EX2, we have the exact same, I'm going to call your attention to. The get file function, ask which you may have.
Question, they're asking if you can go over slide 40.
I know that the add async function is what it's going to call. Judging from some of the looks on the faces in the crowd here in person, this was challenging, right? I promised that it would be challenging. I didn't want to let you off easy. But actually, you might kick yourself when you realize how stupidly simple this is. It just requires you to train your brain to think a little differently about these problems. Take care of making the request, but it does. And then I know I can call th3 with a callback. An active thunk. Can everybody see why this is always going to make sure that they are responded to in the correct order? There's a couple of options here. If I run th1 and I print out the text for 1, and then I run th2, one option is that th2 is already ready to go. It already has a response, in which case it's right away going to call me with text 2. That's one option, because it already had that one there. Another option is that it's not yet got the text 2 ready, in which case I'm just going to keep waiting. But in either case, I know that once it does fire, I do have a text 2. And once I get to th3, there's only one of two options. Either th3 is already finished, in which case when I call it, I'm going to get the value extracted right away, or I'm not going to get the value extracted right away, but I'll wait until I do have a value. So in all possible combinations, this expression, this nested callback expression, is going to sequence my output. And I don't have to worry about any kind of looping through some array or object to find stuff. I know that they're going to be sequenced correctly as a result. Does everybody follow me on that reasoning? Okay? Whether you realize it or not, that's a huge, massive improvement over our previous. And we didn't invoke any kind of library or any fancy thing at all. We're just using functions in a different way. This blew me away when I first realized that this was possible all along. Why on earth did I write so many years, decades of crappy code, not realizing how to use my tools more effectively?
Oh my fucking god. Yeah, that's one of the reasons why I'm looking at this. It's like, oh my god, I'm trying to learn. Jesus fucking. Oh shit. I'm trying to learn how to use this tool in the most effective and efficient way. Because it's, to be honest, that'll be good for me. That'll be good for Eulier from the future. That's all. That's all. That's what I'm doing, is for him.
Because this is significantly more clean and understandable. It's not perfect, but it's way better than what we wrote in exercise 1. Now that I know that that's what I need to come up with, I need to figure out whether it's even possible to solve this silver bullet, this active thunk. So here's how we're going to do that. We're going to observe that there are either line 24 is going to run before line 28, or line 28 is going to run before line 24. Those are the only two possible outcomes. So we need to bridge the two, and we're going to do that by looking at both scenarios independently. So let's imagine, for an example, that line 24 runs first, before line 28. So let's say line 24 has run. That means we got the response back, but we have not yet called our thunk. We're going to need to hold on to that response. Does everybody agree with that reasoning? So here's what I'm going to do. I'm going to, in my...
And as a way to hold that on is to actually store that into a closure.
Have a variable called text. And what I'm going to say is text is equal to response.
Text equal to response. That's right. So what you're doing is just now holding that value. So carry that value.
Now,
right.
On line 30 now, which was the previous line 28, when line 30 runs at a later
line 31, now I have the value.
I have a callback, and I have some response text. So couldn't I just say CB text?
If you pass that callback here.
Does everybody see how I did that? That's only one of our two scenarios, but I just want you to understand how we're bridging. In the one scenario, we're bridging by saving the text and then passing it into the callback at a later time. Okay? Now, let me back up. Let's imagine that now instead that it's line 30 that runs first before line 26. So line 30 gets a callback, but we're not ready to use that callback yet, are we? So what if we save it off? What if we say fn is equal to cb? And then when this line 26 runs, I have a callback to pass my stuff to. I can just simply pass response directly into fn. Does everybody see that? So in either of those two scenarios, I have a way to bridge the gap, and that bridge is closure. Now I just need to put those two solutions together. Okay? So what I'm going to do, I'll start back at scratch. What I'm going to do is set up an if statement to ask for these two conditions. So inside of on line 26, what I'm going to ask is, if fn has been set, then I know that the other one has been called first, right? Because that's the only way it gets set. Which means I can simply call it right away with what I just got. If fn has not been set, I need to save the response. Down here, we're going to do the reverse if logic. If the text has been set, then I know I can just go ahead and send it to CB. Otherwise, I need to save off my callback.
It's dependency inversion. When you need to resolve.
A few of you had that? I had that mind exploding like, what? How has this been around and I just never even knew it? Why didn't anybody ever teach me this in all my years of JavaScript? I don't need some library. I just need to know how to know, I need to know how to better use the tools I already had.
Yeah. I just need to know how to better use a tool that I have. That's one of the reasons why I'm actually looking at JavaScript, bro. A lot of people say, no, it's React, it's like Angular. No, you're technicians, which is a great thing, right? But I want to take a look at JavaScript here and TypeScript.
I've looked and looked and looked for a name for this pattern of bridging the closure of these two states. And really, I've asked functional programming developers and other people, what do I call this pattern? Nobody has any good name for it. So I just call it active versus passive or active versus lazy thunks because I don't have any better term for it. But when I discovered this a few years ago, I started using it all over the place. And in fact, I realized I'd already kind of fumbled upon that solution before in some of my earlier libraries because I needed something like a promise before I had promises. And I'd accidentally stumbled upon something kind of like this in the past, and then I realized, wow, that's actually a pattern I use all over the place inside of the various libraries that I write. So it's a more effective way of using the callbacks and closures that we already have in the language. And again, the takeaway, we have completely factored time as a state out of the equation. We don't have to worry about it. We set this code up once.
Completely. I don't have to worry about time, which is one of the most complex things that you have to do in computer science. So with promise, or this thunk, which is just a value, it's a wrapper of the value. It's a time independent wrapper around a value. So it can be synchronous, right? By creating a closure around that. Interesting. By creating a closure around that. Okay. By creating a closure around that, okay, and then hold the value by creating a closure around that, and then return a function that's going to receive that callback. All right, it can be synchronous or asynchronous. If it has now a callback by the time I call that thunk, which is this routine that will be run independently, time independently. I just only care about that value. When you're trying to know when this function gonna run, in particular order.
This is like plumbing. This is the program code that we write over and over and over and over again. And this is the part where we don't have to worry about time, because that part's already been taken care of for us. So it makes our code fundamentally easier to reason about. Okay, so that's Thunks. The next step when we get back together is to understand how promises add on to that pattern and give us even more of a solution. Promises are not a replacement for Thunks, because inside of my libraries that I'm making promises, I use Thunks. Thunks are a thing that you can use. It's a very lightweight way of solving asynchronous sequencing issues without having to invoke some huge library or some, crazy API or something like that. It's a very lightweight, easy way of doing it. It's going to take some practice to wrap your brain around that pattern. It took me quite a bit of practice. I would highly encourage you, between now and the next time we get together for this workshop, spend some time going back over that. Try that from blank file and see if you can recreate that same reasoning that I just recreated. It'll make our exploration of promises a lot more fruitful for you if you do. That'd be useful.
Completely, man. Front-end master workshops, you gotta be fucking kidding me. Man. Okay. Oh shit. Okay, that makes a lot of sense, especially when you want to use this now thunk, because it's this piece of asynchronous code that is going to be run at any time soon. You just only care about that reference. You just only care about the value of that. So when you call that at any point in time, you're gonna get that value. So here you are now eliminating is the need of handling his time and worrying and thinking about that time, because it's the language itself that is now capable of holding this reference using closure, which is now this nice little bonus feature that JavaScript has. I don't know who in the F thought about this, but this closure thing, that what it does is to now anytime you're returning a function, it's going to carry over the outer lexical scope as a variables that you define out of this. All of these labels and identifiers, variables, and their value. You're going to hold that. All right. And you can use that as a way to store a thing that you want to run after a certain point. Using Thunk. Oh my god. So Thunks are useful when you want to know handling async operations in your code, when you want to hold a reference of that, when you want to hold a reference of that value, okay, at some point in the future. That's what the reason here is exactly when you need to actually is holding that this operation happened at some points in the future, and then you apply that, and then you update the state to that. Yeah, that'll be all for this video. Take care. Bye bye. Oh, okay. The TLDR of all of this is learn how to use your tools and put a practice there. That's all.